Yep, it's sounding really good. And I have to admit, changing these output capacitors did give it a lot more low-end roll-off. And I'll tell you, this, for a little 20-watt receiver, this thing really hits you in the chest. It's unbelievable. So I'm very happy with the amplifier. I'm not touching it. I'm not changing anything from there. The other good thing is this is a really well-built receiver by Rotel. The more I looked at it, few things I really like. And part of it is the tone control section of this is all done with these really nice high-quality film caps, similar to these red ones over here. And so we're really not going to have to do any work in that at all. Controls are all cleaned from the last video. So now what I think we're going to do in this video is we're going to replace the lights and do a little bit of tidying up there. And then we're going to just go over the tuner and make sure it works, and check out the phono stage and make sure it works. And this thing will be ready to go. Okay, so there's two screws, one here and one over here, and this light assembly comes out, and you will have to remove the stereo indicator bulb, and you'll have to desolder this one wire over here that goes onto the end of the terminal. Then we can get to these lights. And you can see some of them are burned out, and we're just going to replace them with these LEDs. Now, before you start soiling your nappy because they're horrible LEDs instead of incandescent, what I use on these is the warm white lights. And actually, when you use the warm white LEDs, they're a lot easier on the eyes than those bright white ones that they normally sell you. So this ought to give it a pretty nice glow. This does have the green colored gel in front, so whatever light you put back there, it's still going to have a green tint to it, which is good. So this should be good, and then we'll never have to worry about these burning out again. These are kind of strange looking bulbs. They're a little bit bigger than a normal fuse, as you can see, but they fit in a normal fuse holder. They're just longer. So I'm going to hang on to these if there's any good. There are a couple of good ones, because these are the ones that will snap into the end snap type connectors, and those are getting harder and harder to find. Like in some of the old Fisher gear and so forth, you see those in the dial lights. Some of them are longer than this, a little bit, longer length, but some of them are this length. So I'll have one or two spares in case I need them down the road, which will be a good thing. So let's pop these all out and replace them. Yeah, there's there's like 3 or 4 of them that are burned out, but there's at least 2 of them that were good. So we like that. Okay, and I'll snap these in, and they just go right in place. And you want to make sure the bulb, boy, these are loose because those bulbs were too big for the socket, so I'm going to have to pinch these down a little bit so they'll fit tight again, and then we'll be good. So let me get the camera out of my face and I'll just gonna take some pliers and just squeeze these down a little bit, just like so, without breaking them, hopefully. And then those should fit a lot better. Okay, the new bulbs are in, and we'll get this back up on there, and then we'll test it out and make sure it works. Okay, so the lights look pretty good on here, as you can see, but I see a couple of problems right now. First of all, the stereo indicator is on all the time. It never goes out, and I think I know why that is. I'll come back to that in a minute. But the other thing I think is pretty amusing, take a look at this dial indicator. If you look very closely at the pointer, notice the pointer itself has tin whiskers on it, just like the cover did in the back. I don't think I've ever seen that. Well, yeah, I guess I have seen that before, but it's been a long time on like old shortwave radios with meters. I'm not going to attempt to take that all apart to remove those and fix it. It just adds to the charm. Now cleaning off these tin whiskers, which I've already gotten most of them off, it's pretty easy. You can use a little bit of alcohol on a paper towel or on a rag, or like I do, I use just a tiny little bit of WD-40 on a rag, and that just kind of helps soak that up. And WD-40 is not a very good lubricant or oil, whatever, but it is a good cleaning product. And then, now I don't like to leave all the oily residue on there. And yeah, I'm getting around this dial cord, but I'm not really forcing it very much. But it does leave a little bit of a residue, but that can be cleaned off, which I will do when we're finished with this. I'll just come up and follow up with a dry rag. And that's it. That cleans that off. Unfortunately, we can't clean the tin whiskers off of the meter pointer, but that's okay. So anyhow, let me finish cleaning this up a little bit, and then we'll come back to this tuner here in a minute, this stereo indicator. Okay, looking inside this thing, I mean, no tin whiskers. It's perfect. It's really strange how those things grow, or I guess you call it grow, inside there. There are some down in the bottom you can see kind of fell down in there. I don't know if you can see that or not. It's kind of dusty in there. It might be dust. It might be some tin whiskers down there, but I'll blow that out with a little bit of compressed air and try to get out of the line of sight and breathing when I do it. But this stuff isn't super dangerous because it's just tin. It's not like beryllium dust and things that I work with at work, which we won't talk about. Anyway, so yeah, let's clean that out, and I think we'll be ready to try the tuner and see how it works. Okay, here's where I think we're going to have some problems. If you noticed earlier in the video, the stereo light was always on. And part of that was because when I went to remove this light, and I really should have used a different tool to do it in retrospect, so that's partially my fault, the glass light bulb cracked. So I had to replace it with an LED, which is actually not a bad thing, but it will affect this circuit because of the way it's designed. And we're going to look at that here in a minute on the schematics. And there is also a way to correct this problem, and I'll show you that as well. But I wanted to also show you a method. If you ever have to remove these glass bulbs and you want to take them out intact from one of these grommets, what happens is these rubber grommets will harden. And this one has not hardened. It's actually still pliable, but it gets sticky, and then it kind of glues itself to the bulb. And then that way, when you pull on that bulb, it'll just break. So what I like to do, and I should have done in the first place, I did it after it was too late and I cracked the bulb, is you take a very small jeweler's screwdriver like this, and you just run it down alongside the bulb and just push it down all the way around. And what that'll do is that'll kind of break that seal, that gluey, whatever, stickiness off of the bulb, and then the bulb slides right out. So just a little word of warning so you don't do what I did. But anyway, now we have an LED in there, and it's not going to wear out, which I guess is a good thing. All right, let's address the problem with our stereo light staying on all the time, because we replaced it, if you recall, with an LED light. And this is kind of a unique little circuit the way they did this. So if you look, they have an incandescent bulb, and it's rated at 14 volts, 80 milliamps. And if you take 14 volts and 80 milliamps, that's going to equate to an equivalent resistance of about 175 ohms, I think, something like that, just kind of quickly running the numbers. And this B4 point right here goes over to our power supply, and you can see there's B4, and all this is a little voltage divider network with resistors. So that means that as you change the loading here, the voltage is going to change based upon how much current draw there is, because this is an unregulated power supply. And these are relatively high resistances. There's a 330 ohm 5 watt resistor here, and a couple of 2.2 Ks in parallel right here. This is an unfiltered, unregulated power supply. So you have these voltage dividers here with no capacitor. So what's going to happen is, as you increase the load here, this voltage is going to drop. So you can see they have a 31 volt rating here, and then in the square it says 14 volts, and what that means is when this power supply is unloaded, it's going to be 31 volts. When it's under load, when you select tuner, because if the tuner is turned off, it'll go up. But when the tuner is turned on and you put the load of that tuning circuit on there, it's going to drop to about 14 volts. Hence the 14 volt bulb. Now here's where it gets unique, or a little bit interesting. At the other end of the bulb, you have these two 3.3 K resistors. So let's just call this like a 1.8 K standard value resistor. They just put these two in parallel to be able to, I think, to take the extra wattage. And when you divide this bulb with this resistor right here to ground, it's enough energy to put some heat on the filament of the bulb, but it will not light the bulb up. So this light is held just below illumination, but it always has current flowing through it through that circuit. Now you can see up here it says 30 volts. See where it says that? And that's because of that 31 volts because this is all high impedance right now until it finds ground. And in the square it says 0.75 volts. So what happens is when your stereo pilot signal kicks on and it sees that 19 kilohertz pilot, it's going to turn on this transistor, which is going to take this point right here to ground. So it's essentially going to bypass these two resistors, and that's going to light the bulb up. Now, why do you think they would put these resistors here? I believe the reason they're doing this is by keeping a standby current on the filament of the bulb and keeping it just below giving off light, it will make the reaction time of that signal a lot faster. So if you have a weak signal where the stereo pilot is kicking in and out real fast, you'll see this bulb flicker on and off really quickly. And so I believe that's why they're doing that. I can't think of any other reason as to why you would want to do that. The problem is when we take this incandescent bulb out of here and we replace it with an LED, the LED draws far less current than this incandescent bulb. So it's going to find ground through this 1.8 K resistor, and it's going to be really happy to just light up all the time. And when this transistor turns on, it'll bypass this resistor to make the bulb, or make the LED draw heavy current, but it won't do anything to make the bulb turn on or off because it's always going to be on. So what I'm going to propose is, because we have this LED in here, I'm going to just lift the terminal, or lift this resistor out of the circuit. So what we'll essentially have is this with an LED. When we do that, my LED, the little LED replacements that I had in there, that's another problem I think we're going to have with this. I thought my LED that I used had the built-in dropping resistor. Unfortunately, I have a couple different versions of these panel lamp LED replacements. The one that I'm using has a little bridge rectifier in it to keep the LED from flickering with AC, but it does not have a dropping resistor. So we'll have to add a dropping resistor in line with this LED as well. And it's not going to be here, it's actually going to be here that we're going to put the dropping resistor. That way, this will act as an open circuit, and when it sees the pilot signal, this will turn on, and then you will have that 14 volts feeding the LED through here to ground. And LEDs react very quickly, so you don't have to worry about holding it partially on. That'll keep us from having to deal with that. So, long-winded description of this, but we're going to lift this resistor, and then we're going to determine what kind of a resistance we need so that this stays in a we don't want this to run real hot. We're going to put that in there, and I think what I'm going to do is I'm going to put like a 4.7K resistor in there, and that should allow the bulb to light up and still not draw very much current. I only want about 5 milliamps or so in there. I think that's what we'll get. So let's put that in there. I'll show you and we'll come back. Okay, here's our circuit. And you can see these were the two 3.3Ks in parallel. I just lifted one leg off of this terminal of them and put a little piece of heat shrink. That way, if they want to go back to, if somebody wants to go back to a incandescent bulb down the road somewhere, it's easy enough to just reconnect this over there and put your incandescent bulb in, and Bob's your uncle, no problem. Here's our 4.7K resistor going to the one lead of the LED, and then the other lead of the LED goes to the 14 volts, which is now 31 volts. And then this gray wire goes up to our tuner board that goes to the pilot detect circuit. So let's see if it works. Okay, we have our Sencor SG80 set to 98.1 megahertz, and we have a stereo multiplex signal being modulated onto it. And so we're just going to have to tune this to 98.1, and I think I got it all in the camera here. And if it works, we should see this red light come on. You can see it is off right now, which was not happening before. And there it is. Look at that. So when we tune into it, the light comes on. We tune off of it, the light goes out. Perfect. And if we look at our oscilloscope, and I have that connected to the record out jacks from the tape recording out jacks, and you can see we have our stereo signal. And if we go through here, and you can see left, right, so we don't have very good separation. That's going to need to be adjusted. Left minus right, left plus right, which they're out of phase, and I do not believe that is correct. So we'll have to look into that. And then stereo. So our left and right channels are out of phase from one another. We'll have to find out why that is. And I will look at the scope and some other things and see if there's a problem as to why that is. Because I don't think we should be seeing that. And if we go to mono, yeah, same thing. So yeah, the left and right channels are out of phase from one another, and that's not right. So now we have another problem to troubleshoot, don't we? Okay, as it turns out, it's going to be a really easy fix. I just hooked this up and I didn't really pay attention to what I was using the scope for previously. And I actually was looking at something where I was using a differential mode between the two channels. And if you look here, I have the invert button pushed in. And if I turn the invert button off, now everything's good. So it wasn't the tuner, it was the test equipment. I would highly recommend anytime you're troubleshooting something, before you troubleshoot the device you're working on, troubleshoot your test equipment. Could save you an awful lot of time, and that's kind of a habit that I'm in now. And I have this set to DC, which doesn't really matter in this case, to the coupling. And you can see now they're both in phase, and if I go to left plus right, nothing changes, left minus right, and now they're inverted, which is what it should be, right and left. So now what we have to do is see if we can get the stereo separation adjustment done. And I bet you if we go into XY mode, yeah, it looks horrible. There's left, there's right. When we have left, it should be straight up and down. When we have right, it should be horizontal. So I'm on left, right. You can see it's not good at all. Left minus right and left plus right and stereo. And you can see they're a little bit separated. That should be a flat line. If both channels are perfectly in phase and everything's good, you should see a flat line. And if I expand this a little bit, you can see very clearly, you see how those lines are separating? It looks like a little oval. That should be a straight line. And if we get our stereo separation adjusted properly, that should be a perfect line. You can see I'm playing with the tuner right now, just tuning. So we need to adjust our separation. Okay, we're going to switch on to right only. And I'm going to rotate, let me show you here. Over here, this is the multiplex board. And we're going to rotate this pot here. This is VR301. And we'll do that as I adjust it. We should make that into a nice straight line. And it should be horizontal because we're looking at the right channel right now. So if we look, it's still kind of distorted. It's not perfect. But there you go. There's a little bit of difference probably in the amplitude, and that's going to be an issue that we may have with the detector circuit or something. So we're going to have to go through the alignment. But if we go back over to here, you can see we got it pretty flat now. And we did that using the XY mode. And again, you can do whichever way you prefer. And there's your left. And we'll sync off of channel 2. You can see that's pretty flat as well, but we can't get it perfect. And part of that, could be the detector circuit. So, and now we should have a vertical line if we go into XY mode, and we do, kind of, sort of. But you can see how it's curved, and the curvature of that line tells us that we have different amplitudes or phase relationship between the two channels as well. So there's something weird going on yet. So we're going to have to go through the alignment properly of the tuner, which is to be expected. Okay, this is actually a really good opportunity where we can actually look at an S-curve using the Sencor SG80 as it was intended to be used, because this tuner doesn't have any PLL chips or any kind of integrated circuitry where you can't get connected to the signals you need. It actually has test points that makes it very easy to set up the equipment. So I'll go over that with you real quickly because I get a lot of questions on this. Now, first thing you will notice is I put a piece of black tape on the calibrate, what do they call that? The variable knob. And the reason being is that if you turn this like this, when you go to this step, the signal is actually smaller, and when you go to this step, it overlaps. If we turn this, we can utilize the entire screen because we're not really trying to measure a time base. We're actually trying to just look at the waveform. So we can see the entire sweep and use up the whole screen. That's not necessary. You can make it smaller or bigger, but just showing you how that works. But I put a piece of tape on there to remind me that I moved the variable control, and so that I can put it back into calibrated mode when I'm done. Because if you forget that and you come back, it'll be just like with the invert button. You'll have to troubleshoot your test equipment. Okay, so if you look at the SG80, the way it's connected here, you will notice that I have 4 connections made to the signal generator. The first one's pretty straightforward. This is your output, and it's just going to just a straight output wire with clips on the end. There's no special terminator or anything. It's just it goes to 2 hook clips. And we have the signal generator set to sweep mode, so it's going to put sweep with markers, and it's going to sweep at 10.7 megahertz, which is your intermediate frequency. And you can vary that a little bit, but we want it at 10.7 because that's going to be the IF for the FM section of this tuner. Now, the next one over, you need a special probe for this. You can make one, but the SG80, if you have the complete signal generator, comes with this cable. And this is called a detector cable. And if you look at the other end of it, I'll show it to you. It looks like this on the other end. And it has three outputs. It has an isolated output, a ground, and then a detector output. Now you would think if we're looking at the detector circuit output that you would use this one, but in this case we want to use the isolated probe. And that'll give us that nice S-curve. And this one just kind of hangs off to itself. And where we're connected is the output of your detector is right here on this test point. So they were nice enough to put a test point there and a ground. And the input for your 10.7 megahertz, where it comes out of the front end, is right here. So we're injecting the signal right at this test point. It's very nice. So with that in mind, when we come up to our scope, you will see we have the vertical and horizontal outputs going to the oscilloscope as I bump the camera. And that's going to channel 1 and channel 2, which is your X and Y, and then you're going to put your scope into XY mode, and you magically get a beautiful looking S-curve. Of course, that's not a really beautiful looking S-curve. It's off a little bit. So we're going to have to see if we can align this, because it is off. And according to the instructions, I'll just put it in front of the camera, they're telling you to adjust T104, 103, 102, and 101. So they have you work backwards. So we're going to look at the detector adjustment first, the ratio detector, and then the IF adjustments. So here are the 4 transformers. This is the ratio detector adjustment, and then this is your 4th, 3rd, and 2nd IF, and then your main first IF is on the other RF board back there. So they want you to start with this, and we're going to work our way back. Now another thing is there's an adjustment on here called marker height right over there, and that, when I adjust that, that's what's going to let us see our markers. So there's actually multiple markers on this. Now I have the markers turned completely off right now. If we turn them on, you can see them just start to appear there like that. And here's your 10.7. And the idea is you want these 3 markers to come down and be centered at the crossover point of your S-curve. And this is off center as well. So we definitely are going to have to adjust the ratio detector. Now the other thing is these cans use just a screwdriver tip, so it's not the kind where you can take the hex tool and run it through the top one and into the bottom. We're going to have to flip this thing on its side to do the alignment so we can adjust the bottom coils, because there's a top slug and a bottom slug in each one of these, and each one's going to have to be adjusted. So we're going to do top and bottom of T104, which is our ratio detector, and I'll show you what the top one looks like when we adjust it, what it does. And you can see it moves the S-curve up and down. We're going to align it to our center line. Then we're going to flip this thing on its side so that we can access the bottom part, and we're going to adjust that. So let me do that right now. Okay, the tuner is now turned precariously on its side, and you can see right here there's holes in the board where we can actually go in and adjust the bottom of each can. So I'll put you back on the scope as we do this, and hopefully I can reach it. All right, here we go. And we'll go back to our ratio detector. Let's see if I can get in there to it. I think this is it. Make sure. Yeah, I think that's where we're at. Yep. Okay, and let me adjust that one if I can get onto it. There we go. And see what that does? That's the bottom of the ratio detector. And we're looking to peak that out. We want it to be at its peak. So we want the S-curve to be as tall as possible. And what I find is when you do this, you can make it look good on the scope, and you still may be able to get it a little better by ear once you get it where you want it to be. But usually this gets it pretty close. So that's T104. Now let's go to our fourth IF, which is T103. And I'm going to adjust the top coil, or the top slug. And you can see it's the same thing. It kind of moves everything around. And that one was pretty close. So we're going to leave that. We'll go to the bottom slug. There we go. And again, that one was pretty good too. So we're not going to play with that. All right, let's go to the T102 top slug. If I can get onto it here. Same thing, that one's pretty close. We're going to leave that alone too. And then go to the bottom slug of that one. And you can see as we get through the peak here, see how the static gets really strong. So that one was off a little bit. Turn our markers down a little. Okay. Okay. And now to our second IF, which is T101. And that was off a little bit. Not much, but a tiny little bit. And let's do the bottom one. If I can get into it here. There. So that's pretty good as well. Now, as you can see, we still don't have our perfect 10.7 megahertz centered here. We really want this to be down here. And unfortunately, it doesn't really tell us about that. So what we're going to do is we're going to try to adjust this a little bit. I need to find out which one I need to get to. Give me 1 second. Okay, so I touched up the first IF adjustment which is on the front end module, which is right here. And there's what we got. That looks pretty good right now. I think I'm going to leave well enough alone. Now again, looking at it visually, it's still going to depend. We're going to actually put a signal into it and tune it in through the tuner and make sure everything's good. And we may have to fine adjust it by ear. So let's take a look at that now. Okay, here we are with a stereo multiplex signal fed in through the tuner, and I'm tuning it in. You can see off frequency. So it tunes right in. It's right on the dial scale. If I go to left plus right, left minus right, right and left, it all looks really good. And it seems to be pretty sensitive. So I'm going to connect an antenna and see if I can tune in some stations.
Valley, being the only one of fireworks sparkler stores.
James really put on steroids and got.
We're fair July 1st through the 9th with 9 big days of food, animals, concerts, and.
Well, I think it's working. And it is pretty sensitive. I mean, you don't get a lot of FM down here, and with all the stuff around here and everything. So it's doing really well. Okay. FM is done. We just need to check out the AM, and in order to do that, we're going to have to make a repair to this antenna right here. Alright, before we do a test of the tuner, I get a lot of questions about this ceramic screwdriver alignment tool. And there's a whole series of these made by a company called Engineer. You can see it right there's the model number of this one. And this company is based out of Japan, and they make pretty good quality tools. But these, I really like them. They're very durable. It is a ceramic tip on the screwdriver, and it's nice because it's non-magnetic. They fit most alignment tools, and they make an entire series of these with different tip sizes. I have several of them. The problem is when you try to buy these online, they can range in price. You can see these listed for, $40 or $50 US. And then you can go on eBay or Amazon or someplace and they'll pop up and they'll be, $10 to $15. The shipping can be high on them. Sometimes the shipping will cost you $10 or $15 maybe because they're coming from Japan. But other times it can be really high, and sometimes it's $5 or $6. You have to kind of set a search, with notifications on eBay, and kind of wait till it pops up and wait till one comes up at a good price, and then you can purchase it. But that's what they are. Another alternative is these are all over the place online. Every online, eBay, Amazon, AliExpress, whatever, has these ceramic screwdrivers, and they're not bad, but you typically have to re-glue these in there because they're just press fit, the tips. So because these will kind of slip around in here and come loose, they will crack a lot more easily than these ones, but they work, and they're very inexpensive. You can buy an entire set of them for maybe $10 or $15 or something online. So that's another alternative. They're a little bit shorter, as you can see, and sometimes you can't always get them down into some of the bigger alignment coils and things, but they work. So there's a couple options. And I like these because they're non-conductive, you can't short anything out, and because they're non-magnetic. So that's why I use them. Anyway, enough about that. Well, I guess sometimes it's better to be lucky than good. Look what I found laying around. It's kind of cruddy. I need to clean it off, but look at this. It's aluminum stock. The thickness is exactly the same. The width is exactly the same. Look at that. So I can trace two of these out with this aluminum and cut it out, and it should be perfect. Okay, here is our old brackets, and here's our new. Worked out pretty well. What I did was those rivets that were in there, I just ground them off with a Dremel, and then I drilled out the center of them and tapped it for a 440 screw, and then I put these little rubber tensioning washers on there, and then I just put a really good coating of Loctite thread locker on each screw. I think we got it. Nice. Until we ship it again. And of course the anal retentive among us may want to have these painted, but I opted not to paint them simply because these are made of aluminum, and paint doesn't stick very well to aluminum, and I would prefer seeing the silver color than seeing paint that's scratched off with silver scratches beneath it. So that was my option. If the person who gets this would like those to be painted, they can feel free to paint them. Too much noise. So it is picking up, it's fine. I think that I'll throw it on the signal generator and check the sensitivity and selectivity, but I believe, just like the FM, I think it's pretty close to being right on with the alignment. Down here on the bench, there's so much noise and everything, it's hard to pick up any substantial AM, especially during the day. At nighttime it gets a little easier, but it's working. So this receiver is mostly done. I think we can put it together. I will probably do one last thing. We'll check out the phono stage to make sure it is working. And after we do that, we're going to call it a wrap. Okay, we have our little adapter in there. And we connected to the phono inputs. Let's get some music started. Just make sure it works. Sounds fine to me. I mean, of course, we could do an exhaustive test, but hey, this is not a really high-end receiver. I just wanted to make sure the phono stage worked and that the the equalization was still decent. It sounds, to my ears, it sounds okay. Is that the best way to test it? Absolutely not. But if something were really wrong, you'd hear it. So I think we're good. Everything works, and I'm going to put the cover on this. All right, all put together. It looks really good. I took a little bit of this Milsec furniture polish and just kind of went over it, and it turned out very nice. There's no scratches on this thing hardly at all. I mean, it's in really nice condition. It cleaned up beautifully. So this is going to be a nice little receiver that somebody can put in their den or even in their living room if they like. And it should perform very well for a long time. Not a super high powered amplifier, but you really don't need one in most cases, as we've seen. So I think this one's going to end up going to Flipside Records and get sold there. And usually when I send them there, they don't even make it a week and they're gone. And these are just unbelievable how much demand this vintage of gear is still in. So anyway, we come to the close of another restoration or service or whatever you want to call it. So you know what I'm going to say. Until next time, I wish you all peace, joy, happiness, and good health in your lives. And we'll be back real soon. I have a whole list of things I want to do, and I already know what's going on the bench next, so I'll keep that for a surprise. Take care, everybody. Bye-bye.